Hey there, Joel here, and welcome to my channel Math World. Today is the part 3 series of solving riders from the chapter Triangles, and always I would tell you that students get worried and tensed up when they talk about riders, and I think solving this third proof by now you should be good at it, and this is what your situation should be whenever you are talking about riders. I hope you're practicing more and more problems, because unless and until you practice, you will not be able to solve them. So without wasting any more time, let's straight away jump to the question. And it is, quadrilateral PQRS is a parallelogram. Point A is the midpoint of TR. Line AR intersects QS at the point B and ray QP at the point T. Prove that TB is equal to twice BR. After a long time, you got a question where the proof question is a very small one. Okay, so let's see how to go about with it. Let's draw a figure, and the figure is something like that. First of all, you should know what is a parallelogram. You have already studied them in the 9th standard. If you don't know, I'll just tell you in brief. PQRS is a parallelogram, which means the opposite sides of this figure are parallel and they are also equal. Okay, which makes PQ equal to RS, QR equal to PS. That's it. Point A is somewhere on line PS, and then PQ is extended and these lines are joined, and also you are told that A is a midpoint of TR, which means TA and AR are equal. So I can write TA is equal to AR, which is given to us. Next step, I can say TP is equal to PQ. Now you'll wonder, how is that possible? I've just spoken about TAAR, and how are you saying that TP is equal to PQ? Now, if you remember your 9th standard portion well, you also studied something called as Midpoint Theorem. I hope you remember, which says that if a line is drawn passing from to a triangle where it is passing to the midpoint of one side. Now in this case, point A is the midpoint for TR and it is parallel to the base. Then it will surely go and touch the other side at that midpoint, which makes TP equal to PQ. That's the midpoint theorem. If you don't know what is midpoint theorem, then I guess you need to Google it out or check the 9th standard textbook for it. Okay, so I can write by midpoint theorem TP is equal to PQ. I'll mark that as well. Okay, next step, what we are going to do is we are going to consider this triangle, which you can see in orange color, that is BTQ, and this triangle which is blue in color, BRS. So let me write them, and in those triangles I can say these angles which are marked in red color are called as, I hope you know, they are called as vertically opposite angles. And this part we have already studied probably in the 7th standard or maybe before that as well. So vertically opposite angles. Next I can write BRS is equal to BTQ. Now what is happening over here is, we have already discussed that PQRS is a parallelogram. So whenever a line is extended on the sides of a parallelogram, automatically they'll also be parallel, and now they are making an alternate angle which is in Z shape. Now if two angles of one triangle are equal to two angles of another triangle, then by criteria for similar triangles, we can say that these two triangles BTQ and BRS are similar by AA similarity test. And if triangles are similar, I can write the corresponding sides to be equal. So TB upon BR is equal to TQ upon RS. If you are having trouble in writing the corresponding sides, do let me know in the comment section. I will be happy to make another video telling you how to write the corresponding sides well, because most of the times students make mistakes in writing the corresponding sides. They write it in a wrong way and then lose out marks on that. Okay, so TB upon BR is equal to TQ upon RS. Now if you look over here in the figure, I can say that CPST is the part of it. Okay, then PQ is equal to RS, so I've put the lines over there to tell you that both of these sides are equal. Now if I say my RS is say 2 centimeters, then PQ will also be 2 centimeters. Similarly, TP will also be 2 centimeters because they are equal. So in short, TQ will be 4 centimeters. If I say RS is 1 centimeter, then TQ will become 2 centimeter. And now since they are ratios, I've just written them as 2 upon 1. Okay, so TQ becomes 2, RS becomes 1. Okay, now all I have to do is cross multiply. So 1 multiplied by TB will be TB, and 2 multiplied by BR will be twice BR. And that is what we are asked to prove in this entire rider, which we have already done. It's that simple, and I hope you have understood this rider. If you did, please don't forget to hit the like button, share and subscribe to the channel so that you don't miss out any more videos coming up in the future. Thank you and God bless you.